Hi, my name is Bahadur Akhmedov. In this video lecture, we are going to discuss measures of variation of a sample or a population. So essentially, we would like to know how much the data points are spread. So we can do this in the three different ways. So one is called the range. It is simply the subtraction of a minimum point from the maximum point, or we can do this using the standard deviation, which have a sophisticated formula when we are going to find the distances between all of the points and the mean, and the variance, which is simply the square of a standard deviation. So let's discuss why the variation or the measures of the variation might be important. So let's say I've got two samples. So essentially the results of an exam from the group 1 and group 2. So let's say the table above corresponds to the group 1 and the table below corresponds to the group 2. So what does this mean in those tables? So this is essentially dot plot. So this means that I've got the data set so the student's grade is 5, 5, 10, 15 and 15. So if you remember how we make the dot plot is we found the number 5, right? And we put the dot above this every time when we've got the result which corresponds to the 5. So the second group have the points which corresponds to the 0, 5, 10, 15 and 20. So this is essentially the grades of the first group and the second group. So if you find a mean for the first group, it is going to be equal to say 5 plus 5, which is 10 plus 10 plus 15 plus 15 divided to the 5, which is like 50 divided to the 5, which is going to be equal to the 10. And if you find a mean for the second group, it is going to be equal to the 5 plus 0 plus 10 plus 15 plus 20 divided to the 5. So I think it is going to be again 50 divided to the 5, which is also equal to the 10. Well, you see, so by the means, the group 1 and group 2 are the same. So the mean of the group 1 and group 2 are the same. But I can see here that the grades in the group 2 are more spread, right, than in the group 1, so where the spread is smaller. So it is essentially we need to figure out how to measure the spreadity of the points in order to compare the two groups, for example. So I would guess that the performance of the group 1 is better because there is no one who got 0. So most of the students' performance are better than in the group 2. So let's learn how we can do this. So essentially for the range, so the first measurement of the variation is going to be called as the range. And before we do this, let's introduce the notation of a sample point. So we are going to denote x1, x2, x3, and so on, xn of an n sample point. So if you've got a sample with 5 grades like 5, 10, 10, 15, and 20, so we are going to denote x1 to be equal to the 5, x2 to be equal to the 10, x3 to be equal to the 10, x4 is equal to the 15, and x5 to be equal to the 20. So this is simply the notation because later on when we are going to denote, for example, the mean, it is going to be the summation of x1 plus x2 plus and so on plus x5 divided to the 5, or sometimes we are going to denote this as the summation of xi. I goes from 1 to the n divided to the n. So the range of a data set is simply going to be the ratio, the difference between the maximum and the minimum value of a data set. For example, as this writing, India has 1 satellite used for the military and intelligence purposes. Japan has 3, Russia has 14. So find the range of a sample value is 1, 3, and 14. So in this case, the minimum value is 1, the maximum value is 14. So that is why the range is going to be equal to 14 minus 1, which is equal to the 13. Well, the range is going to tell you how much the data points are spread. So essentially, if you've got like 1 point here and 1 point here, then lots of points there, the range is going to be simply taking the difference between the minimum and the maximum points. But this is not so good because it doesn't include in its calculation all of the other points. So you probably would want to have a more reliable measure of the variance, because the thing is that if you've got two outliers, the range is going to be huge. So the range is very sensitive for the outliers, and we need to figure out another measurement which is less sensitive for the outliers. And another way of calculation is going to be called as the standard deviation. So what we are going to do is, so the idea of standard deviation is to find the distance, the average distance between all of the points and the mean. And let's do this together. So first of all, I'm going to find the mean. So the mean is equal to the sum of all of these numbers. So this is 0 plus 5 plus 10 plus 15 and plus 20 divided to the 5. And that's going to be equal to the 10. And now I'm going to find the distance between all of the points and the 10. So the distance between the first point and the mean is going to be simply the difference between the first point and the mean. And since I don't want to have a negative number for the distance, I'm just going to square this. It is going to be the distance between, so this is the distance between the first point, x1 and x bar, which is going to be equal to the 0 minus 10 in the square, which is going to be simply 100. So the distance between the second point and the mean is going to be equal to the 5 in the square, which is 25. The distance between the third point and the mean is going to be equal to 0. So the distance between the fourth point and the mean is going to be equal to the 25 again, and the distance between the fifth point and the mean is going to be equal to 100 again. So it is 20 minus 10 in the square, which is 100. So what I'm going to do is, so this is all of the distances between the points and the mean, and I would like to take the average of all of these distances. So in this case, I'm going to sum 100 plus 25 plus 0 plus 25 plus 100. And then I'm going to divide this as the number of the distances, which is equal to the 5. So in this case, it is going to be equal to the 250, right? So 250 divided to the 5, which is going to be equal to the 50. So this, and now, so since I took a square, I artificially made the distances a little bit bigger, right? Because I'm squaring the distances, the differences between the points. And the reason why I'm doing this is I don't want to have the negative values for the distances. And at the end, I need to take the square of this 50 so that the number is not going to be exaggerated. It's not going to be too big. So the standard deviation is going to be the square root of 50, which is about 7, I would say, right? So the idea is again like this. So if you've got the points, so what we do is we find the mean of all of these points, then we find the distances between the points. So let's say this is going to be the first distance, the second distance, the third distance, the distance number 4, and this is distance number 5. And the standard deviation is going to be the average of all of these distances. So obviously, if the points are more spread, then the average value of the distances is going to be also bigger and bigger. So now let's just summarize all of these things which we have discussed and put everything into the formula wise. So if you're given the data set, so we are going to find the distances between all of the points and the mean. We square them, and then we sum them, and at the end we divide this to the number of the sample points minus 1, and then we take the square root. So please note here that in our calculations, or in our idea of measuring the standard deviation, we found the distances between all of the points and we sum them, and at the end we divide this to the n, which is the sample size. But in the formula of the standard deviation for the sample, we are going to divide this to the n minus 1. So it is only true when we are calculating the standard deviation of a sample. And the reason is, so if you've got a population, you're taking the samples which are smaller and smaller, right? And you want that the sample standard deviation, which is denoted as the S, is going to be as close as possible to the population standard deviation, which is sigma. So that is why we are going to divide this as the n minus 1 always. But once we are calculating the standard deviation of a population, we are going to divide this to the n. So this is the only difference in the formulas to calculate the standard deviation of a sample or the population. And the reason is by just dividing this to the smaller number, we would like to make this as bigger artificially so that it is going to be closer to the standard deviation of a population. So this is how we are going to calculate the standard deviation of a population. Instead of n minus 1, we're going to divide this as n. So please note that I'm skipping the indices in the summation notation. So this is something which is called the Einstein notation. So this is already meant that I'm going to sum this from 1 to the n, right, by subtracting the xi minus x bar in the square. So I'm just going to neglect this because it should be more or less understandable. And the variance of a standard of a population is going to be simply the square of a standard deviation. So once you find the average distance between all of the points, you don't need to take the square root again in order to find the variance. So well, the standard deviation and the variance is going to give you the same value conceptually, and the reason is why we're taking the square root, it is going to be the more realistic the distances, more realistic average distance. And the reason why we don't want to take the square root is essentially we don't want to deal with the radicals. So one of the biggest applications of the standard deviation is to identify the positions of the data points in your data set, or identifying the outliers. So if you remember, we defined an outlier, which is the value which is far away from other values. And I was always curious to know, what does it mean this far away mathematically, right? Because in maths, we don't really define these things by our feelings. So what we want is, we would like to define a strict notation. What is going to be meant by far away? So in order to do this, let's find the mean and the standard deviation of the sample points. So I've got the sample six points, right? So 1 is equal to the 0, 2 is equal to the 5, 3 is equal to the 10, 4 is equal to the 15, 5 is equal to the 20, and 6 is equal to the 100. So obviously this 100 is far away from the other. So I would like to know whether it is sufficiently far away from the others so that we can call this point as an outlier or not. So first of all, I'm going to find a mean. So the mean of all of these points is going to be the summation of 0, 5, 10, 15, 20, and 100 divided to the 6. It is going to be equal to the 25. Right, so let's check this out. So I think it's going to be 5, 15 plus 15, 30, 50, and 100. So 150 divided to the 6, it's 25. And at the same time, the standard deviation is going to be calculated by just subtracting every point from the mean and squaring them and summing them and divide this to the 5, because we are going to calculate the standard deviation of a sample most of the time. So if you do this using a calculator, what you get is, it's going to be like 25 in the square plus 20 in the square plus 15 in the square plus 10 in the square plus 5 in the square plus 75 in the square, and this is all divided to the 5. Then we have to take the square root. If you calculate it, it is going to be equal to the 37.41 roughly. So now, once we know what is the standard deviation and what is the mean, what we can do is we can measure the distance between the mean, which is equal to the 25, right? So the mean is here. It is denoted as the x bar, and this point. Okay, so let's find the difference. So x bar minus the x, or x minus the x bar. It doesn't matter how we calculate this. So let's do this in this way. So x minus x bar is equal to the 100 minus the mean, which is 25, is equal to the 75. Okay, so the distance between the mean and the point is equal to the 75, and this is more than one standard deviation, 37.45, but it is even bigger than 2 standard deviations, which is roughly 74.82, right? Which is equal to the 74.82. So in this case, the distance between the point and the mean is bigger than 2 standard deviations. So whenever the distance between the point, a point, and the mean is bigger than the 2 standard deviations or smaller than minus 2 standard deviations, we call this point as an outlier. So this, in this sense, this definition that the point is far away now is defined as strictly. So far away means that the point is far away from the mean more than 2 standard deviations. So in this sense, I'm going to redefine the definition of an outlier. An outlier is the value which is far away from the mean more than 2 standard deviations. Either, for example, you've got x minus x bar more than 2 standard deviations, or x minus x bar is less than minus 2 standard deviation. For example, if you would got x to be equal to the minus 100, the mean is equal to the 25, right? And the standard deviation is equal to the 37.41. Then the difference is obviously is going to be x minus x bar is going to be equal to the minus 125, which is obviously more than 74.82. Oops. Less than, sorry. So, which is obviously less than minus 2 times the standard deviation, which is 74.82. So that is why this point x, which is minus 100, is called an outlier. So this is one of the applications of the standard deviation. So there is another rule, which is more sophisticated rule, which is called an empirical 68, 95, 97.7 rule for the data which has the bell-shaped distribution. So if you know that your data has a normal distribution or bell-shaped distribution, then you can know the distribution of the points which are located between the standard deviations. So now we know that if you just draw the mean, so the mean is going to simply divide the splits your area under the curve exactly to the 2. So essentially the area which is more righter from this line, this vertical line, or which is more lefter from this vertical line is going to be equal to the 50%. So now I'm just going to draw the vertical lines which are far away from the mean by 1 standard deviation. So it is essentially x bar minus standard deviation and x bar plus the standard deviation. I'm going to draw the vertical lines at the 2 standard deviation distances from the mean and 3 standard deviations between the mean. So it appears we can identify the amount of the points between which are located between 1 standard deviations distance. So essentially, the amount of the points which are located between mean and this 1 standard deviation is equal to the 34%. So at the same time, amount of the points which are located between between this point and this point is going to be equal to the 13.5%, or essentially the amount of the points which are located between the mean and 2 standard deviations is going to be equal to the 47.5% from one side, and in total it's going to be equal to the 95% or something like this. So then the amount of the points which are located between these 3 standard deviations is going to be equal to the 97.7%, and the rest, like the amount of the points which are even bigger than 3 mean plus 3 standard deviations is going to be equal to the 1%. So essentially, if you remember, so we calculated 100 minus the 25 in our previous example. So the x minus x bar was even bigger than 2 standard deviations. So it was either here, right, or either here. So essentially, it is this point 100 would be in the top 2.5% of your sample points. So essentially, the points, all of the points, if you've got like 100 points, then 68 of them are going to be here within 1 standard deviation of the mean. So out of all of your 100 points, 95% of them is going to be between two standard deviations, within two standard deviations from the mean. And among all of the points, 99.7% of them are going to be within 3 standard deviations from the mean. So it gives you some understanding where is your point is essentially in your data set. So for example, in university, sometimes the scholarships or some stipends or grants are distributed among the top 5 or top 2 or top 1% of the students. And essentially, if you've got your grade after the midterm exam, you can figure out where is your grade essentially. So for example, the midterm exam results have the bell-shaped distribution. Usually this is what we expect. With the mean 50 and the standard deviation 15, what is the percentage of the students whose result is more than 75? So essentially 75. Okay, so I don't know what is 75, but I would say more than 80, right? So 50 plus 2 standard deviations times the 15 is equal to the 80. So the amount, so let's just make this 80. So amount of the students who've got more than 80 is going to be equal to only 2.5%. So this is like, so this point here is going to be equal to the 50. So the x bar plus the 2 standard deviations is 80. And the amount of the students more than 80 is going to be equal to the 2.5%. So if after the midterm exam, your professor announces that the mean is equal to the 50 and the standard deviation is 15, and your result is more than 80, so let's say 85, then you should know that you are in the top 2.5%. So this kind of empirical rule is also used in order to distribute the grades in the universities or in other different occasions. Well, today we've learned about how we can measure the variance, the easy way to do this using the range when we are going to subtract the minimum value from the maximum value, but it is very sensitive for the outliers, and it also doesn't include all of the points in its calculations. And more sophisticated way to calculate this is called a standard deviation, when we are going to find the average distance between all of the points and the mean. And the standard deviation is very useful to understand the position of the points in your data set. Well, thank you very much for your attention. I hope that this was helpful for you.